So up until now, we've been using the TVM Solver to solve investment problems in which we have a single investment. So we take some money, we invest it all up front, and then we wait 1 year, 2 years, 10 years, whatever it may be, and then we see how much money is left. But more realistically, it's likely that an investment would be not a single investment, but an investment over time. So, for example, you set aside $10 every paycheck, or you pay every year into an RRSP or every month into an RRSP, and how much money are you going to have at some point in time in the future. So that's what this PMT category is. We left it at 0 in previous problems, but in problems that we're going to be working on in 1.5, this is going to have a value, and that's the amount of money that is regularly set aside every pay period, so whatever this payments per year happens to be. And then typically we'll take those payments and we'll determine how much money has been accumulated at some point in time in the future, which will be the regular payments plus the amount of interest that they earn over time. Keep in mind that these payments are being made over different period of times, so they accrue interest differently. Thankfully, the TVM solver will just take care of all of that for us behind the scenes. So here's a problem involving regular payments. So we have Ida gets paid bi-weekly, so every 2 weeks. Whenever she gets paid, she invests $25 into a high interest savings account, and that has an interest rate of 2.25% compounded monthly. How much money will be in the account in 5 years? So $25 gets paid every 2 weeks, and on top of that, that money earns interest over time. Okay, so she gets paid bi-weekly. So bi-weekly is once every 2 weeks, so that would be 26 times. And that's going to go into P over Y. That's how often payments are made on this investment. The interest rate is 2.25%. So we put the interest rate as a percentage, and it's compounded monthly. So C over Y is going to be 12. So this is compounded monthly. Now, you'll find in some of these problems that P over Y and C over Y are the same. Sometimes they're different. In this case, they are different. Just realize that P over Y is how often the money is being paid on the investment, and C over Y is how often the money is being compounded. Okay, how much money will she have in the account in 5 years? So for N, this is going to be 5 times how often the payments are being made. In this case, that's 26. If you just put 5 times 26 into your TVM solver, it will automatically compute this answer of 130. There is no initial investment. Instead, there are regular repeated investments of $25. And what we want to do is figure out what the present value is going to be. So these are the values that we're going to take and put into our TVM solver. So our N was 5 times 26. Interest rate was 2.25%. There was no present value, but instead there were regular payments of $25. So negative 25. These payments were made bi-weekly, so 26 times per year, and interest was compounded monthly, so C over Y 12. And then we're going to highlight what we want to figure out, which is the future value, so how much money will be there in the future. We press alpha, enter, and we're going to round this off to 2 decimal places since it's money, so $3,438.19. So $3,438.19 would be the amount of money that was earned through this investment over 5 years. I'd just like to highlight, by the way, that I use real world values for this. So I found that high interest savings account at this point in time can earn up to 2.25%. So just setting aside $25 a paycheck in 5 years' time leaves Ida with roughly $3,500. So even small investments over time, when interest gets accumulated, can give us a large amount of future value. Problem 2. So Sophie wants to save money towards a vacation in 3 years, which will cost a total of $7,000. She's found an investment which will pay 3% interest compounded monthly. How much will she have to set aside each month in order to afford the vacation? Okay, so let's break this down step by step. The vacation will cost $7,000. So that's the amount of money that Sophie is going to want to have in 3 years' time. That is the future value. Positive because that's the amount of money she's going to want to receive. She's found an investment which will pay 3% interest, compounded monthly. So 3%, C over Y is 12. And then we're asked how much will she have to set aside each month? So she's making monthly payments. So this 12 is because the investment was compounded monthly. This is 12 because there are monthly payments being made. So the values are the same for this question, but they come from different places. How much will she have to set aside each month? So we're trying to figure out what those monthly payments are. There was no lump sum investment in this case. And she wants to save this money for 3 years. So this will be 3 times how often the payments are made per year, which is 12. And putting that calculation into the TVM Solver will give us 36. So these are the values that are going to go into our calculator. Let's do the calculation now. So N was 3 times 12. The interest rate was 3. She wants to have $7,000. And P over Y and C over Y are both going to be 12. Whenever you change this P over Y, it always sets C over Y to be the same thing. But realize that they don't have to be the same. And if you wanted to adjust the second value, you could. That being said, in this question, they are the same. What do the monthly payments have to be? So we're going to highlight PMT, press alpha, press enter. So we got negative 186.068, rounding this off. This would be 0.7. So the monthly payments would be $186.07. So these are the monthly payments which would be required in order to have $7,000 in the account after 3 years with monthly payments. Final problem. Aminata makes regular payments of $250 every month into an account which earns 4% interest, compounded semi-annually. How many years will it take the account to grow to $20,000? Okay, 4% interest, compounded semi-annually, so that's 2 times per year. So 2 because it's compounded semi-annually. The payments are $250. That will go under PMT, negative because we have to pay it out. And that's every month. So P over Y will be 12 monthly payments. And we're asked how many years will it take that to grow to a value of $20,000. So no lump sum investment, regular payments instead. How long will this take to grow? So we want to figure out X for this problem. So our interest rate, 4%. The monthly payments were $250. We want this to grow to $20,000. Monthly payments, compounded semi-annually. So let's calculate N. So alpha, enter, and we get 71.0978. So 71.0978. What are the units for this? The units are going to match whatever the payments per year are. So if the payments per year are monthly, this will be in months. However, note that the question asked us how many years will it take for this account to grow to $20,000. So we will have to convert those months into years. So to do that, we'll have to do a short side calculation. So we have 71.0978 months. And if we divide that by 12, this will tell us how many years it will take for that to grow. And this is just a calculation we can do on any calculator. So in doing this, I got 5.9248 5.9248 years. but this value has to be rounded up, because how many years will it take? Well, it will have occurred by the end of year 6. So it will take 6 years for the account to grow to $20,000. And that is with those regular $250 monthly payments. Okay, that's an overview of using the payment feature in TVM Solver.